Okay, so now what we're going to do is look at this summation from 1 to infinity of 1 divided by 5 plus the square root of n. So keeping in mind of what we just did, if I were to pick or try out a value, the first thing that I might think about doing is just getting rid of that 5 and looking at the summation from n equals 1 to infinity of 1 over the square root of n. This is the same thing as 1 over n to the 1/2 power. So we have a p-series. And not only that, we have a p-series where p is equal to 1/2. P is equal to 1/2, which happens to be less than 1. Because it is less than 1, we know less than or equal to, realistically, it diverges. Because we know that if we were to use this, we would want to make 1 over the square root of n equal to a sub n, because if a sub n diverges, b sub n is going to diverge. Okay, so now what we needed to make sure is that a sub n is less than or equal to b sub n. So we said a sub n is 1 over the square root of n. That has to be less than or equal to 1 over 5 plus the square root of n. And then if I do what we just did, which is multiply by the denominator on both sides, this would mean 5 plus the square root of n is less than or equal to the square root of n. And that's not a true statement. So this is not something that we can use for this particular comparison test, because 1 over the square root of n would have to be b sub n. And if b sub n diverges, then it doesn't necessarily matter what a sub n does. We're not going to be able to tell anything from it. So we're going to pick something else. And what we're going to try now is something similar. We're still going to use a p-series, but we're going to use the most generalized, iconic p-series that we know. And that happens to be the harmonic series. So we're going to try 1 over n. This is a p-series where p equals 1. Because it is equal to 1, we know that it diverges. And because it diverges, that means we know 1 over n needs to be a sub n. So if we're back to a sub n, less than or equal to b sub n, we have 1 over n, and it has to be less than or equal to 1 over 5 plus n, square rooted. Okay, we're going to do the same thing. I'm going to multiply both sides by the denominator, so we have 5 plus the square root of n on this side, less than or equal to n. So now we need to see if this is a true statement. One of the ways that we're going to do that is by looking at a table to make some decisions. So I want n, I want 5 plus the square root of n, and kind of decide what I have going on here. And then because I know I have a square root here, I want to look at some easy numbers that are going to give us some nice values. So the first one I'm going to look at is 1. If I put 1 in for n, the square root of 1 is 1. We have 5 plus 1, so 6. So far, this is not going well for us, because that means it is bigger than n. Okay, we're going to try 4. The square root of 4 is 2. 2 plus 5 is 7. Okay, so we're still not in a great place for this, but we're going to try 8, or we're going to try 9. We have the square root of 9 is 3. 3 plus 5 is 8. So we are finally at a point where, oh gosh, we're finally at a point where that n value is actually bigger than 5 plus the square root of n. And if we do some work here, we could move the 5 over and multiply both sides, or square both sides to get rid of the square root, and then try to factor it the best I can. And we're going to find out that this is true for values greater than or equal to 8. So this works for n greater than or equal to 8. Because I can go from 8 to infinity, this actually works for us. So as long as we're going from 8 to infinity, and it doesn't switch again, we are good to go. So what we now need to do is say, because these values work for us now, they're less than, a sub n is less than b sub n, we now can say the summation from n equals 1 to infinity of 1 over 5 plus the square root of n, it diverges because 1 over n diverges. The direct comparison test is not horrible once you know what to do with it. It's only not super great because you have to decide when things are bigger or smaller. And then you also need to pick other functions to kind of help you out here.